everyone, in this video we are going to learn some concepts, points, definitions in coordinate geometry. Okay, first thing that we are going to learn in this chapter is how to find the distance between two given fixed points. Let x1 and y1 be coordinates of point A and B of coordinates x2 and y2. Now I join them using a straight line to make a line segment AB. Now our aim is to find the length of AB. Now, as you see here, x coordinate of point A is x1, so this point will be x1, and this point is obviously y1. Here will be x2, and this point will be y2. Now, I extend this line to meet this vertical line. You know that x-axis and y-axis make a 90-degree angle. They are perpendicular to each other. Now, here the distance between these 2 points is the value x2 minus x1, and here will be y2 minus y1. And you clearly see here you have a right angle triangle in which AB is hypotenuse. So using Pythagoras theorem, by Pythagoras theorem, we will have AB is equal to now a square of this side, which is x2 minus x1 squared, plus the square of the other side, which is y2 minus y1 squared. The second point we are going to learn in this chapter is to find coordinates of midpoint of a line segment. Now, here we have a line segment labeled AB, A of coordinates x1, y1, and B of coordinates x2, y2. Now our aim is to find coordinates of the midpoint. Midpoint, denoted by M, is the point whose distance from both ends is the same. So it is equidistant from MA and MB. Now it's so easy to find M. So we know that each point has two coordinates. X coordinates, which is the halfway of x1 and x2. So x1 plus x2 divided by 2. And y coordinates, which is y1 plus y2 divided by 2. So M will be the midpoint of line segment AB. Now let's see an example considering these 2 points that we just learned. The point M with coordinates 3 second and negative 11 is the midpoint of the line segment joining the points P, with coordinates negative 7 and 4, and Q with coordinates A and B. Now find A and B. Now, here midpoint is given, so we know that midpoint will be obtained by halfway of x1 and x2, which are here, for example, let xp be x1 y1 and here x2 y2. So, and y1 plus y2 divided by 2 will give you y coordinate of the midpoint. So 3 over 2 will be equal to negative 7 plus a divided by 2. 2 and 2 cancel out each other, so a will be 10, then 4, and let me write y coordinate of the midpoint, which is negative 11, is equal to 4 plus b over 2. First we do cross multiplication, it will be 22 is equal to 4 plus b, so b will be negative 26. So Q will be of coordinates 10 and negative 26. Now let's see one more example. Three of the vertices of a parallelogram ABCD are A with negative 5, negative 1, B negative 1, negative 4, and C negative 6, 6, and negative 2. Now, as the first part, find the midpoint of AC, and part B, find the coordinates of D. Now let me first construct a simple parallelogram to see what we are going to do actually here. So it's a parallelogram AB here. It A, B, C, D. A is given minus 5, minus 1. B is given minus 1, minus 1, minus 4. C is given 6 and negative 2. And D coordinates are unknown. Now, first part, you're supposed to find midpoint of AC. Now, so it is here. So M of midpoint of AC will be minus 5 plus 6 over 2 and minus 1 plus negative 2 over 2, which gives you half, and negative 3 over 2. Now, part B, it says find coordinates of D. Here, I construct the other diagonal. We know that it is one of the major properties of a parallelogram. Diagonals meet each other at the center and they are actually bisector of each other. So this part is equal to this part and this will be the same as this. So M, which is midpoint of AC, is also midpoint of BD. Now let D be X and Y. So X plus negative 1 over 2 should be, we know already the midpoint of AC, which is the same as BD, so I put it 1 over 2. So X will be 2, and for y plus negative 4 divided by 2 should be negative 3 over 2. So 2 to cancel out. So y will be 1. Now d will be 2 and 1. Now let's see one more example. The distance between 2 points P with coordinates negative 2a and Q with coordinates a minus 2 and minus 7 is 17. Find possible values of a. Now it's a matter of distance formula here, so I should use distance formula. What was distance formula? It was root x2 minus x1 squared plus y2 minus y1 squared. Now x2 minus x1, so it will be root a minus 2 minus minus 2, which is plus 2 a squared plus minus 7 minus a squared is to be 17. Now it will be root 2 to cancel out, it will be a squared plus 49 plus 14a plus a squared is equal to now 17. So to get rid of this radical, I square both sides. So it will be 2a squared, these two are like terms, plus 14a plus 49 is equal to 289. Then you have a quadratic equation which simplifies to a squared. When you transfer to the other side, all are divisible by 2. I divide it by 2. It will be 2a squared plus 14a minus 240 is equal to 0, which simplifies to a squared plus 7a minus 120 is equal to 0. So it will be a minus 8 times a plus 15 is equal to 0. It gives you a is equal to 8 and a is equal to negative 15 as the second answer. In this part, we are going to discuss gradient, definition of gradient, gradient of parallel and perpendicular lines. Now, first, let's see what gradient is. Gradient or slope in some mathematics text, you see the name a slope for gradient. A of coordinates x1, y1 and b of coordinates x2 and y2. Here I join them using this straight line. Then again we know that it is representing x1 and y1 here, x2, and here will be y2. Extend this line. Now gradient, which is denoted by m, actually is the ratio of rise over run. Someone as if is going up this hill, then the ratio of rise over run will be known as gradient, or you can say vertical change or change in y over horizontal change, which is Vertical change is known as y2 minus y1, and horizontal change is x2 minus x1. So y2 minus y1 over x2 minus x1 will be giving you gradient of this line AB. Now parallel lines. Parallel and perpendicular lines. Now consider these two lines, L1, L2. Gradient of this line is M1, gradient of this line is M2. This symbol shows that they are parallel. If two lines are parallel, it means that their gradient will be the same. Now, what for perpendicular lines? See, it is L1, L2, it is M1 and M2, and they make an angle of 90 here. When two lines are perpendicular, gradient of the second one is reciprocal and opposite sign of the first one. Or if you do cross multiplication, you could say M1, M2 is negative 1. If two lines, gradient of two lines have these two properties, one of them, actually they are the same, then it means that the two lines are perpendicular to each other. Now, let's see some examples. Here, the coordinates of three points are a k minus 5, negative 15, b 10 and k, and c 6 and negative k. Find the two possible values of k if a, b, and c are collinear. Now, if three points are collinear, it means that they lie on the same line. For example, here point A, B, and C. So gradient of AB must be equal to gradient of BC, or you could say gradient of BC is equal to AC, doesn't matter. So here, first I find gradient of AB. Gradient of AB will be equal to K minus 15 over 10 minus k minus 5 is equal to minus k over 6 minus 10, which simplifies to k plus 15 over 15 minus k is equal to minus 2k over minus 4. Then you can simplify them. So if you simplify and do cross multiplication, it would be 2k plus 30 is equal to 15k minus k squared. So here is k over 2 actually. Then minus k squared. Now this equation will be simplified to k squared minus 13k plus 30 is equal to 0, which can be factorized as k minus 3, k minus 10 is equal to 0. So you have two answers, k is equal to 3 and k is equal to 10. as the two possible answers here. Now let's see one more example here. The vertices of triangle ABC are A with coordinates 11, 3, then B with coordinates 2k and k, C of coordinates -1, -11. Now part A, find the two possible values of k if ABC angle is 90 degree, and part B, draw diagrams to show the two possible triangles. Now, for the first part, as it says ABC, for example, A here, ABC is to be a right angle. It means that gradient of AB times gradient of BC must be -1 as they are perpendicular. Gradient of AB is equal to k minus 3 over 2k minus 11 times minus 11 minus k over minus 1 minus 2k, which is equal to -1. Now, if you multiply them, it will be, and doing cross multiplication, it will be k minus 3 times, here you can factor negatives here, here this fraction can be written as 11 plus k over 1 plus 2k, because if you factor negative from both numerator and denominator, so you can cancel out negatives, so both become positive. K minus 3 times k plus 11 is equal to minus 2k minus 11 times 2k plus 11. Sorry, 1 here, 2k plus 1. So here 2k plus 1, this one, 2k minus 11, these two multiply by the other side, -1, this is the -1, then you have k minus 3 times k plus, here is 11. After you simplify and you take everything to one side, it will become 5k squared minus 12k minus 44 is equal to 0, which simplifies to 5k minus 22 times k plus 2. So it gives you two answers here. K is once -2, and the other one is 22 over 5. These are the two possible values for k. Now, second part, part B. Now you have once k was 22 over 5, which is 4.4, then B will be 8.8. Just replace it, k, replace in coordinates of B. B will be 8.8 and 4.4. And if the other possibility for K was -2, if we replace it, B was -4 and 2. Then you can easily construct them. Here X, Y, for example here A, which was 11 and 3. Then B will be somewhere here, which is -4, -2. And C here, a little bit more, -1 and -11. Here will be C. Then join them. They make an angle of 90. Now the other possibility is for when B is 8.8 and 4. Let me construct it here. Here, for example, A is somewhere here, which is 11.3. B will be somewhere here, 8.8 and 4.4. And C will be here, -1, -11. Now let me erase. I put A here to make a 90. You can draw it accurately, scale your paper, and draw a completely accurate graph. Now, so here 90-degree angle, 90-degree angle, ABC, and you see in both cases ABC is a right angle triangle.